Now we want to keep talking about the Wumpus world problem to understand how exactly does the agent reason. We saw the agent making logical conclusions. Okay, we have written all this, like inferring where pits are, Wumpus might be. To understand how the reasoning works, we need to explore the foundations of logic. There are four things: syntax, semantics, models, and entailment. Syntax, semantics, models, and entailment. So, what is a syntax? What is a syntax? So, syntax is something which defines how these sentences are written, their structure. Okay, so syntax, like let's say an example of sentence in arithmetic: x plus y equal to 4. X plus y equal to 4. This is a syntactically valid sentence. But let's say you write x 4 y plus equal to. Will that have any meaning? No, it will not have any meaning because this is not syntactically valid. But syntax alone does not tell us if something is true. That's where semantics comes in. Okay, semantics comes in. What is semantics? Let's see what is semantics. So semantics gives meaning to sentences. Semantics defines truth with respect to possible worlds or models. We'll talk about models, okay? So semantics comes to assign or ascribe meaning to sentences. It defines truth with respect to different possible world. Like the sentence x plus y equal to 4 is true in a world where x equal to true and y equal to true. Y equal to 2, right? So x equal to 2 and y equal to 2. This will ensure x plus y equal to 4 is true, right? So that gives semantics. That goes semantics. So logic connects language, syntax, with meaning, semantics, through truth in possible worlds. Now let's see what is a possible world or model means. A model is a model. We call it a model. So this is a very important concept, okay? So a model is a mathematical description of one possible world. It specifies which sentences are true or false, okay? So if a sentence alpha is true in a model M, we say M satisfies alpha and write it as M satisfies alpha, okay? The set of all models where alpha is true is written as M alpha. Set of all models where alpha is true. For example, in arithmetic, in this problem, we have seen x plus y equal to 4 includes all combinations of x and y that add to 4. Like let's say one world, let's say W1 will be where x equal to 0, y equal to 4. Another world will be x equal to 1, y equal to 3. Another world will be, or model, we can also call it a model, x equal to 2, y equal to 2. Another model will be, or world will be, x equal to 3, y equal to 1. And a fifth model is also possible where x equal to 4 and y equal to 0. So all this satisfy the statement alpha, right? So do you see this? All this satisfy the statement. If we call it alpha, this statement, so that means all this satisfy the alpha that x plus y equal to 4. So models help us define truth formally. Every logical statement has truth defined across all possible models. Okay? Now we have to verify in all this model, is this statement true? If I would have said x equal to 5, y equal to 0, will it be true? It will not be true. So now that we have truth, we can talk about reasoning. We say that a sentence alpha entails beta, while alpha so like if we can say that alpha entails, let's take a different color, and we say alpha entails beta, another sentence. Okay, so in which situation? So this is written as alpha entails beta. Okay, so if in every model where alpha is true, beta is also true, then we can say alpha entails beta. In other words, if the world makes alpha true, it must also make beta true. Like, let's say there is a alpha, a sentence which is saying x equal to 0, and there is another statement beta which says x y equal to 0. Do you think alpha entails beta? Alpha entails beta. So that means if in this statement alpha is true, that means x equal to 0, will beta will also be true? Yes, it will be true, irrespective of the value of y. So alpha entails beta is true. Right? If it's a multiplication, so if x equal to 0, then xy equal to 0 as well. So entailment means truth preservation. The conclusions logically follow from what we already know. Okay, from what we already know, the conclusion logically follows. So one thing I would like to tell you here, so let's say there is the pit, we were talking about the presence of a pit. Let's say at a particular point, we are trying to see that what we are trying to see, if a particular place there is a pit or not. Let's say there is pit in 1 2 2 2 or 3 1. Okay, we were talking there can be a pit in 1 2 2 2 or 3 1. Okay, if we say this as let's say pit at 1 2 is a statement, we are checking its truth. Pit at 2 2 is another statement, and pit at 3 1 is another statement. We are trying to check the truth of this. So what are the different possible models? Like here, the different possible worlds. So if we define it as A, if we define it as B, and if we define it as C, what are the different possible combinations of A, B, C? So these are 3 variables. So this will have 2 to the power 3, 8 possible combination. Like let's say 0, 0, 0. That means none of them have any pit. 0, 0, 1. C has pit while AB does not. 0, 1, 0. 0, 1, 1. 1, 0, 0. 1, 0, 1. 1, 1, 0. 1, 1, 1. So all of them have pit in this. So these are the possible worlds in which this is satisfied. Okay, these are the possible values. But in some of those worlds, the truth holds. In some, it does not hold. So we have to check where the truth holds through the entailment requirement, which we'll be seeing next.